For this example, we're going to look at the two-sample t-test. In the 2019 administration of the SAT, 1,400,229 students claimed that English was their only first language versus 269,381 claimed that another language other than English was their only first language. And we compare their groups. So the mean math SAT score for the English-only group was 530 with a sample standard deviation of 117. And then the mean math score for the another language group was 543 with a sample standard deviation of 117. And we want to know, is there evidence of a significant difference here? Something that's discernible between these two groups? And we're going to do a test at a 0.01 level of significance. So let's go through our four-step process here. And as always, in order for us to answer this question, it's good to always define our hypotheses as well as our parameters that we're looking at. So I'm going to use mu since we're looking at math scores, which are quantitative. So we're going to use the means to be able to compare these. And we have two groups here. We have those that say English was their first language. So I'll just put EO for English only. And then we also have the another language group, something other than English. So I'll use AL to represent another language. And of course, we can just define what these are. So these are the mean scores, mean math SAT scores for the English only group. And this is the mean math SAT score for, and we're looking at the another language group. Again, what is it that we're trying to estimate here then? Or not again, what is it that we're trying to test here though? Is there a difference? Is there a difference between these two groups? Because as we can see in the samples, it does look like that the another language group was a little bit higher than the English only group. So is that a discernible difference, or is that something that's just due to the nature of the sampling variability, or just the variability we'll see in these two populations? So let's go ahead and define our hypotheses. So for our null hypothesis, again, what we're assuming is that these two, there is no difference. They're basically the same. So we can say that English only minus the another language group is equal to 0. Basically, if these are the same, then their difference would be a 0 difference. And we're just trying to see if there is a difference. So for our alternative, we can say that the difference between those things, it does exist, meaning it's not equal to 0. And again, since we're comparing two means, the method of two independent groups, the method that we've learned is that this is going to be a two-sample t-test. So how do we perform this test? Step 3. Well, we're just going to, again, use ArtStat or some other technology or statistical calculator to get the test statistic and the p-value. So let's look at how we can do that. So on artofstat.com, if we go to the web apps, again, we're going to look at comparing two means. Because since we're looking at two quantitative variables, we want to compare the means between these two groups. So once we open this up, again, we are looking at two independent groups, so we'll leave it on this one. But what we want to do is choose summary statistics, since those are the values that we are given. And again, we will name an appropriate response variable. So I'll just put the math SAT score is what we're measuring between these two groups. What are those two groups? Let's give them some appropriate labels. I know we have the English only, as well as the another language group. And now we can put in our sample size, mean, and standard deviation for each of these groups. So those are given to us. So our sample size, which these are technically large samples because we're taking basically the entire population of the 2019 administration. So we have the 1,400,229. And we have a sample mean of 530 and a sample standard deviation of 117. And we'll do the same thing with the another language group. Here we only have 269,381. And for the sample mean and standard deviation, it's given to us as 543 and 117. And lastly, what is the method that we're using here is no longer a confidence interval, but rather a significance test, a hypothesis test. When we look at our alternative, again, we see that it's a two-sided alternative with a not equal sign, so we can leave that as two-sided. And so we get our results here. So you'll see that it actually gives us the null and alternative as we wrote it. They use mu1 and mu2, but that's English only and another language, which matches how we wrote ours. But more importantly, it gives us the test statistic and the p-value. So these are the values that we're going to report here. And we can just copy and paste that in, or copy it and write it in. Right, so there's our step 3. Finally, what are we going to do is interpret what does this actually mean. So our step 4 is our conclusion. And as you can see, we have a small p-value, which is definitely less than our alpha of 0.01. So let's make these conclusions. So we're going to compare the p-value first, since the p-value is less than 0.01. What does that tell us about the null hypothesis? We reject the null hypothesis. And of course, if we're rejecting the null hypothesis, what is our conclusion? Is that our alternative is true. That the difference is not 0. That basically a significant difference or a discernible difference does exist between these two groups. So we have that evidence to show a significant difference in mean math SAT scores exists between the English only and another language group. And there we go. As we can see, step 1, we have our hypothesis. Step 2, we know the method we're going to be using. Step 3 is we do that method with the calculations. And of course, step 4, we are able to write our conclusion based off of our p-value.